What follows next is a walkthrough of creating a model based on a specification. I will first go through the specification of the system we are modeling. Then you will see me creating a model from scratch up to a point where we have a complete model matching the specification and we can generate tests from it. The system that we are modeling here is an instance of traffic lights. So we have two-way traffic light in a crossing of one-way streets. We have one light for the north-south direction and then another light for the east-west direction. That's it on a high level. Detailed requirements for our traffic lights are specified here. So the traffic lights, as we know, can be in four different states at any point in time. There is the red, yellow, green, and then blinking yellow. And then, of course, this state of the light we see as the pole showing the corresponding light at any given time. Initially, both lights must be in the state blinking yellow. Then there is a control interface to this system. And when a start command is received from this control interface, then the north-south light transitions into red and east-west transitions into green. A control command stop will transition both lights back to blinking yellow regardless of the state that the lights are in. Then the next requirements 5 and 6, they define the obvious fact that the lights must always be the opposites of each other. When the other one is green, then the other one must be red, and vice versa. Then the requirement 7 states the normal time-based cycle for these traffic lights. So one traffic light is always green for 15 seconds, then turns yellow for 2 seconds, and eventually transitions to red. And after 3 seconds of this, the other light then turns yellow for 2 seconds and then goes green. Then in addition to this normal behavior, both streets and both lights have a sensor that detects approaching traffic from either north or east. And these sensors only have an effect in these two stable states of the system, which are the states where the other one is when one of the lights is green and the other one is red. And here are then the rules that define how these lights change their state based on the signals from the sensors. So here goes. If the light in the state green detects approaching traffic, and if less than 5 seconds of the normal 15-second green period is remaining, then this green period must be extended by 5 seconds. But if there is more than 5 seconds of this 15-second green period remaining, then nothing happens. So the idea here is that if there is more than 5 seconds remaining, then there is no need to extend the period because the car will still have time to go through the traffic lights. If then in the light in the state red detects approaching traffic, then if we have been red for less than 15 seconds, or the other light has been green for less than 15 seconds, then if the light in the green direction has detected a car less than 5 seconds ago, then we do nothing. So here the idea is that if there is a car approaching from the other direction which is already green, then we don't just turn red on that car. But if the light in green direction has detected a car more than 5 seconds ago, then this green to red transition, which is defined by the step 7 here, or the requirement 7 here, must be started. So in the opposite case, then we assume that the green car has already had time to go through the lights, and we can then change the green in the other directions, direction. Then if we have been in red for more than 15 seconds, then regardless of the conditions on the other street, this green to red transition as defined by step 7 must be started. So this is of course a bit of a simplification of real traffic lights, but still we have a specification that is non-trivial enough so that test design is more than just enumerating simple scenarios. And the thing that makes this more than just trivial is the fact that we have these different timers here and then conditions that depend on each other. So that's it for the specification, and what we then do next is that we get into the real thing and we start modeling.